Imagine waking up at 2 a.m. to get a glass of water. You walk into the kitchen, turn on the tap, and clean water just flows. We rarely think of the invisible infrastructure that makes all this possible. Water treatment plants. These plants are incredibly complex. Physics, chemistry, and biology are constantly interacting, and operating conditions change minute by minute. Yet most plants are still run manually. Operators have to continuously monitor changing parameters, often without extensive technical training, and they are frequently stressed too thin. That means we are always exposed to the possibility of human error. For something as fundamental as safe drinking water, even a small mistake can have serious consequences. Traditional threshold-based alerts don't really help. Imagine receiving an alert at 2 a.m. saying chlorine is too high. Knowing what happened isn't enough. You also need to know why. That's where an AI intelligence layer can help. The goal isn't to replace operators, but to help them make faster, informed decisions. Let's inject a chlorine dosing fault and speed up the simulation. I'll manually trigger the diagnostic agent, although it normally runs every 2 minutes. Within a few seconds, we have already received multiple alerts. The system is powered by multiple specialized AI agents. The first alert predicts that the pH will soon violate the compliance threshold based on its current rate of change, and it recommends corrective actions before the limit is breached. The second alert detects critically low chlorine and identifies a likely chlorine dosing system failure as a root cause. Now, instead of overwhelming operators with raw alarms, the system explains what is happening, why it's happening, and what actions should be considered. Another feature I'd like to highlight is the AI Copilot. The first mode is report, where operators can generate reports for any time period using natural language. The request is translated into SQL through a controlled translation layer, making report generation both simple and secure. Reports can also be downloaded and shared. The second mode is chat agent. Operators can ask questions like, why is the chlorine low right now? The agent retrieves relevant plant data, correlates information across different sensors, and explains the likely cause using the same reasoning pipeline that powers the alerting system. This gives operators immediate context instead of forcing them to manually investigate dozens of sensor readings. Now let's take a look at the architecture. The backend is built using Google Cloud ADK, Gemini, and Cloud SQL, while the front end is hosted on Firebase. Every few minutes, the system analyzes incoming plant data using three deterministic agents focused on sensor health, process health, and water safety. These agents rely entirely on mathematical model, statistics, and engineering rules. There is no LLM involved at this stage. Their findings are then passed to root cause agent that correlates information across the plant, followed by a prediction agent that forecasts future conditions. Finally, Gemini converts those structural findings into clear, operator-friendly explanations and recommendations. The architecture is intentionally designed with safety in mind. The first two layers are completely deterministic, using mathematical models and rule-based logic with zero hallucination risk. The LLM is only used at the final stage to explain findings that have already been validated by earlier layers. Every alert is fully traceable back to the underlying evidence, ensuring operators remain in control while benefiting from AI-assisted decision-making.